Hello and welcome to another session of the Raytracer challenge by James Buck, where I'm implementing a raytracer in Rust, a language which I've never used before writing this raytracer. So I started actually learning the language Rust with this raytracer and this video series. So you can see how I struggle to learn Rust from the beginning while implementing a raytracer here. All the material you may need to follow along is linked in the description down below. So there is a link to the GitHub repository, to the video series and so on. So please feel free to check this out. If you have any questions, I'm always happy when you comment or ask them or contact me, for example, via Twitter or something like this. If you are interested in those episodes I'm creating here, please subscribe and hit the bell to be informed once a new one comes out. In the last session we implemented transformation of patterns, and as you can see here in my raytracer REPL, which is by the way compiled to WebAssembly version of the raytracer we are creating here, you can reach it under raytracer.xyz if you want to play around with it. We implemented, as I said, patterns and transformation on patterns. So we can now transform those patterns here, which you can see here, for example. They are first of all transformed into the object space of this object and not lying in the world space anymore as it has been before. And we can transform them further. Like here, we are scaling this thing and rotating it so that it is in a 45-degree angle, which it would always to which it would always. It would normally be like this one, which is only scaled. And what I the last time said during our session, it is not so ideal that, let me see, that we can only specify this rotation in radians. For now, we have this YAML parser, which we implemented, which actually is capable of parsing all of those structures here and transforming them into the needed Rust data structures we want to have internally to feed into our raytracer to have this result then. And it would be quite nice if we could do something here like degrees and then like, for example, 45 instead of giving this value as radians. And as you can see here, or you might not be able to perfectly see this. Let me make this one smaller so that you can. There is a warning here, an error, which tells us that this radians key is needed and that the raytracer wants it in order to create this rotation here. However, we are now going to implement in this very quick session, hopefully quick session, let's see, a way to enter degrees here instead of radians. I'm thinking in the future we might have something like a possibility to enter more complex values, not only the numbers, but something like that we can have, for example, some types here as well, so that the system could automatically, if we have something like radians and we put in there 55 degrees, the system could automatically transform this into a radian. But we don't have that yet, and I'm only thinking about this at the moment. So the more practical and easier way would be to have something like degrees here instead of radians, or the possibility to specify both. So yeah, let's see, I guess, if we can do this. So I've opened the same YAML file here that you have seen here. Let me quickly copy this one with our change to the degrees, because that is what we want to use for testing our implementation later on. So I'm just putting this one in here, and as you can see, should be able to see, there we are. We have now our degrees in here. So if I now try to render this, it won't work, of course, or at least it shouldn't work. We will see. So cargo run release binary, which was the binary. I'm always forgetting the name. I definitely need to rename this one. Chapter 09, chapter 09 render YAML. And then we are putting the YAML file in there. And if I do this now, actually we should be told that this cannot be read. Yeah, and as you can see, this is exactly, oh no, you can't see. As you can see now, this is exactly the same error as we have seen in our browser REPL, as the browser REPL essentially runs the same code, only compiled to WebAssembly. So what we want to do now is to implement this for the system to understand degrees and to convert the degrees into radians. So where would we start for this? Let's take a look. I guess we have our world loader here, our YAML world loader, which is this one, and there should be a position somewhere where actually a transformation is parsed. So let's see. This is visit striped pattern. Yeah, this is I guess the right position, and there we are actually visiting the transforms. So this list of transformations, which you can see here, we are visiting this one here. We are actually using this as well, of course, in a position where we are visiting transformations like here on the body object, as it is essentially the same thing. We want a transformation matrix in the end, and the structure is the same. So let's see, what could we maybe do here in a way that is useful for us. So actually this one is visiting transform. Yeah, visiting transform. So all of the different transforms like translate, scale, rotate, and so on. And there, yeah, there we are already. There the position is where we are parsing radians. And what we want to do now is we want to allow the system to not only parse radians, but to parse radians or degrees, I guess. So we would simply check if there is one or the other key. We would need to set a priority order. I would say radians always comes before degrees. And then we are taking the value and converting it and returning it. So yeah, let's see. I guess we would start by not having this one here anymore, but I guess self dot calling a new function because we need it more than once. Yeah, I guess this would be a good way to do it. So visit, we could call it visit radians or degrees, and we would put in there, let me see, the transform hash. Actually, this is already it, I guess. We are putting in the transform hash, and we want the radians back. Yeah, so let's see. Let's implement such a function, or maybe let's implement it above this one. So visit radians or degrees. And first of all, we want the reference to a mutable self, and then we want the transform hash, which would be a reference to a YAML hash, I guess. And we want to return a floating point? Yes, we would return a floating point as we are returning radians there. Okay, so let's see. First of all, we would need to see that which of those things is in there. So let's see, we could do an if. How did this work? I guess I could call something like, yeah, exactly, contains key, and we want the key here, which would be, come on, radians? Yes. And if we have this illegal may contain only, oh, not single quotes in Rust, double quotes, yeah. So transform contains key radians. If we have radians, I guess we could simply return, or we don't need the return even, because it will be automatically. We could hash to hash value to float, and we would put in the transform hash, and we would tell the system we want the key radians, don't we? And we want to shortcut out if this, we of course need a parser result of type F64 here, and try expression alt, what? Wrapper, okay, try expression alt have incomplete types. Wait a second. We are returning, yeah, we are returning this operation here, which might error out. Okay, so this is okay as well, I guess, because we are not internally using the result and therefore need it unwrapped. We want to return it directly, so this will be a result then. Yeah, okay, this is fine. So if we have the radians case, we are already finished here, and it should work. And if we have the wait a second. If we now have degrees, we need an else if, I guess. So we need an else if, and we want that we want to know from the transform hash if it contains the key degrees there. Yes. So again with the quotation. I'm sorry, I've written too much TypeScript and JavaScript in the last time for work, so yeah. I'm kind of still in the flow of another language, need to get my mind into this again. So yeah, let's see. So if we have this one and contains key, and we have this degrees thingy here, then we will do let degrees equal self hash value to float, yes, transform hash, and we are putting in there degrees, and this time we need the question mark because we want the unwrapped result here in order to use it again. So we have this one, and now we need to actually calculate the radians from the degrees before returning them, which is essentially quite easy. It should be, let me see, 360 degrees are 2 pi radians, so we have degrees divided by 360 multiplied by 2 pi, or degrees divided by 180 multiplied by pi. Actually, this should be it already, and we need to wrap it in a k this time. Oh, and we cannot divide this one here because this was an integer. Let's see. And now we have the last else branch. The last else branch would be that we don't have either radians nor degrees, which would be kind of bad. So let's see how we are formatting our errors here. Let's steal this there and let's put it in there so we can create a corresponding error. Expected to find at least one of radians or degrees at, there we will put in the path, yes, and I guess this will be it. And then we just put the path in there and we have our error. And now we should already be able to use this function here. What have I done there? Oh, there is of course now missing a question mark here. And we want to use this one for all of those transformations which do rotation. Let's see, where do we have something like radians as well? We have it in our new code. Yeah, I guess this one can go then. I guess we already changed everything, so maybe it should already work. Let's first run our tests again to ensure we didn't break something in a catastrophic way. We didn't. Everything works as before, and maybe I can render the thing now. Okay, so this one is actually rendering, which seems nice. So let's see. Let's open up the main camera here. Okay, it still is rotated 45 degrees. So let's ensure that we are doing the transformation right. I will write a test in a second, I guess. But where is it? Where is the... Come on, there are degrees, 45. Let's make it 65. We should be able to see this. If you are thinking about why the first one renders so much more quick than the second one, it's that the first camera here actually is a 128 by 720 image, and the second one is a 4K image. So of course it's a little bit slower. So yeah, seems to work, because now we have 65 degrees could be correct, I guess. Let's try 90, for example, which should be but yeah, there isn't that much that we could do wrong in the calculation there, so I guess it should actually work out. Let's see. Yeah. Seems okay. Okay, so this seems to work out. So let's quickly write a test for it, I guess, and then we are already finished with this session, which was really quick then, but I'm glad, because I don't have that much time for it at this point in time, at this moment. So let's quickly add a test. So there should somewhere be something we could maybe steal and modify. Wrong, translate, transform. Let's see something with a transform rotation somewhere. Yeah, this one, for example, we could steal this one, and then let's see. Rotate. Rotate X by degrees or something like that. So okay, let's see. We don't need to rotate a pattern specifically. It is enough if we simply do something like rotating a body, because as I've said, it's using the same transformation structure there and the same passing code. So let's do a 45 degrees here. And we are asserting now that it is not an error. So we want to unwrap it. We don't want to unwrap the error. We want to unwrap the thingy here. And actually this one would then give us a world, I guess. And some camera hash map thingy that we don't need at the moment, so let's not think about that too hard and too much. Let's see. So our world should now contain actually a body, world 0. So let's see. Let's assert that world.len, I guess, is 1. I'm not 100% sure how this world struct actually. Let's see. Where is I want this world type here. So let's, no, this is not what I wanted. Okay, no idea what this is. So let's quickly take a look in this world struct. There it is, bodies. We are not taking a look at the right field there. So I want the length of bodies, and I want, of course, an equal comparison here. So let's check. And now we are taking this body out of the world there, just to make sure that we can easily compare it, and we can, I guess, get the transform out of this body by simply calling transform. We may need to, we may need to import the trait, but now we should have the transformation matrix. Perfect. And now we can do an assert equals. We want a matrix with the rotation around what axis did I do it? Rotate Y, and 45 degrees is pi half, isn't it? So pi half should be 45 degrees. Do I need to import this constant, or where's the problem? Or maybe I just missed the resulting transform I want to compare it with here. Transform, there we go. Okay, so I guess, where is my test run command? Let's see if this test, it does not. Okay, why does this test not run? Let's see. We seem to have a problem here with regards to what actually? This does not seem right. It seems rotated around the wrong axis or what? Wait. Did I do something wrong here? First of all, this should be rotate Y by degrees, and then I used type rotate Y, and I used degrees 45. And is this actually right? Is 45 degrees? No, wait a second. 45 degrees is not pi divided by 2, it's pi divided by 4, because 2 pi is a full 360, so 1 pi is 180, 90 is therefore pi halves, and yeah. So it's a quarter of pi. And if we have a quarter of pi, hopefully this test will run. Yeah. Okay, that's nice. So we are now capable of rendering using degrees. And we even have created a test for it. So yeah, I'm quite happy that this was possible this fast, and we now can specify degrees instead of radians for our transformation matrices. And thanks, I guess, for tuning in again to this session and to exploring with me writing raytracer in Rust. And I can only thank you, and if you liked it, please subscribe and hit the bell to be informed once the next session is out, and I would be glad to welcome you again. So have fun and bye!